Hi everyone. In this screencast, we're looking at using Intake-ESM, a data cataloging utility built on top of Intake, pandas, and xarray. So the way you interface with Intake-ESM is providing a pointer, in this case could be a URL or a path, to an ESM collection definition file. And this is a JSON file that conforms to the ESM collection specification. The ESM collection specification is defined in this document, which basically provides or explains the structure and the content of ESM collection. So in summary, an ESM collection provides metadata about the catalog, telling us what we expect to find inside and how to open it. So in this case, this is our ESM collection file. It's hosted in this GitHub repository. And we'll take a look at what's in there. But for now, let's start by importing intake. So Intake-ESM itself is an intake plugin, and what ends up happening is that at import time, intake is able to register Intake-ESM as one of the plugins, and this is made available under the OpenESM data store function. So now I can look into the registry. I can see that Intake-ESM is here, and the first thing that I'm going to do is basically point Intake-ESM to this collection file. If I print this object, it will tell me how many entries are in there. So under the hood, the catalog is a CSV file, which is loaded as a pandas data frame. I can basically take a look at this pandas data frame, and as you can see, I have columns which are my collection attributes, and so every row in this data frame or database corresponds to a data asset. In this particular case, every asset is a xarray store, which is hosted in Pangio's Google Cloud Storage. So as for instance, for this particular row, you can see all the attributes for that. I can take a look at how many or what columns do I have in my collection or my catalog using pandas API. So now let's basically try to find unique entries. Like in this case, I can just call this unique method by passing in like a list of columns or attributes that I'm interested in. So in this case, I'm interested in knowing what the unique source IDs, what are the experiment IDs, and what are the table IDs. As you can see, it gave me the count and the actual values. Now that I know this, I can actually go ahead and actually start querying the collection or the catalog by basically providing keyword arguments that corresponds to the name of the attributes and what values I'm interested in. Go ahead and execute that. So what this returns is a collection object similar to what we had before, but this is now a subset of the original one, as we can see. So we started with 28,100,000, and now we're only left with 97. So basically 97 entries fulfill this condition provided in this query. Now I can again look at the unique values for different attributes. In this case, I'm looking at the activity ID, the source ID, and so on. So now, one of the best things about Intake-ESM is that it provides utility to actually load the data directly into xarray datasets. So in this case, what I need to do is basically provide my collection subset and just call this to_dataset_dict method and pass in some keyword arguments. So now if I do this, this is going to take some time. So what's happening in the background is that we're basically taking all the 97 entries and we're grouping them into compatible groups. And each group will then be put into its own xarray dataset. And what we get is basically a dictionary of xarray datasets. Got to print the keys here. This is going to take some time. Just go ahead and execute that. And in the meantime, what we can now discuss is basically what is in the JSON file. So the JSON file that we're using here, a second. So we can open this JSON file. So in the JSON file, as you can see, so we have these different keys, the catalog file, which actually points to this CSV file hosted in a Google bucket. And this is where the catalog is really hosted. And then these different attributes. So basically, these are the things that we're expecting to find in this catalog file. So we have this assets section that basically tells us what are the format of the data. In this case, it's ZAR. What is the column name that actually stores the path to the actual assets? In this case, it's called zstore. And then we have this section here, aggregation control, which basically provides the logic on how to combine different data sets. So in this case, we're basically saying group by these attributes, and then from there we have these aggregation types. So join new here, we're saying we're going to create this new dimension in the xarray dataset called member-id. So we're going to concatenate dataset across a new dimension called member-id. If the asset actually have this particular attribute, or in this case, if it has the dcpp underscore init underscore year, and then these options here are keyword arguments that get passed to xarray methods such as merge and concat. And then we have this union here, which is basically the merge in xarray. All right. So now I go back here. Again, this is going to take some time, and this is because I'm actually not on Google Cloud, running locally, and the HTTP calls take some time. So if you're on, ideally you would want to do this locally since the data is on the cloud. So the best thing that you can do is actually move your compute on the cloud so that the compute is close to where the data is located. But basically, after this, once you've called the .keys, what you get back is a dictionary of xarray dataset, and then you can get back basically, or ask to extract whatever keys you're interested in, and then you can do these xarray operations. In this case, I'm getting this particular dataset going from this particular key, and in this dataset, I basically have an oxygen variable. So I'm selecting the first time value, and the first level value, and so this would be so this would be the sixth member ID, and then I'm plotting that, and that's what this looks like. I could do the same thing here by now providing another search query. In this case, I'm interested in this particular variable for this particular grid label for this particular table ID, which corresponds to the frequency. And what I get back is basically an instance of so basically it's also a collection object. And if I wanted to, I could do more searches on this. So I could basically chain these searches. And as you can see at the end, So this is the main, so this was the first search, which gave me 29 entries, and then after that, I did this new search. Basically, I chained this new search on top of the previous search, and then I got my final subset, collection subset, to be only 18 entries out of the 29 that I started with. Okay, so thank you very much, and that these pages here that provides more details, and I encourage you to check out the intake documentation, and if this is of interest to you in terms of building catalogs for different data sets, feel free to reach out on the GitHub page here in Intake-ESM, or in ESM collection spec repository, and then we'll help you out with that. So yeah, thanks.